Okay, for the do now, you're asked to solve for x. And if you look at every equation, we have a fraction set equal to 0. And if you remember, setting a fraction equal to 0 means you're setting the numerator equal to 0. So for number 1, you're going to set x squared equal to 0. And that would mean x would equal 0. For number 2, it's x minus 1 equals 0. And if you add 1 to both sides, when x equals 1, that will make the equation equal to 0. For number 3, you're going to set 19x minus 30 equal to 0. And if you add 30 and divide by 19, you have 30 over 19. And for number 4, 3x plus 1 set equal to 0 will result in a negative 1/3 for x, because if you subtract 1 and divide by 3. So this is a skill we're going to be using today. So I want you to use your handout and you're going to fill in the blanks as we work through this. In algebra, whenever you're asked to have a fraction equal to 0, we would set the numerator equal to 0 and solve for x. That's what we just did in the do now you just worked on. Now in calculus, they're going to ask the question, find the x value where the tangent line to the curve is. So tangent line, don't forget, is referring to, you're basically getting into the slope. So when is the slope equal to 0? It's when the curve is horizontal, okay? Or that tangent line is horizontal. So if they ever say find the x value where the tangent line to the curve is horizontal, they are referring to a 0 slope. In algebra, when a fraction is undefined, that generally means the denominator is equal to 0. Okay, and then you would solve for x. This is just like finding the vertical asymptotes. In calculus, they will say find the x value where the tangent line to the curve is vertical. So vertical lines have undefined slopes. Okay. So let's do this example. We're given x cubed plus 7y to the 4th equals 13. Find the coordinates of point P where the tangent line to the curve is horizontal. So when they say tangent line, they mean the slope of the line. If the slope is horizontal, or the tangent line is horizontal, the slope is going to be equal to 0. So what we need to do is take the derivative of this equation, and we're going to solve for dy dx, and we're going to set it equal to 0. So I hope you would agree that the derivative of x cubed is 3x squared, and the derivative of 7y to the 4th is 28y to the 3rd dy dx. Because again, this does not say y equals. Every time we take a derivative of a y, we need to have dy dx. Also, don't forget the derivative of 13 is 0. So we're going to get the dy dx isolated. So we should first, looks like we'll subtract 3x squared and then ultimately divide by 28y cubed. So we're subtracting 3x squared and then we'll divide by 28y cubed. Okay? So what's happening now is we have our equation for the slope, and we go back to the question, when is the tangent line to the curve horizontal? The key words here means the slope equal to 0. So we're going to set the slope, which is this equation, equal to 0, and then we're going to solve for x. And again, just like the do now, if you have a fraction equal to 0, we're going to just set the numerator equal to 0, which is negative 3x squared equals 0. If you divide by negative 3, you still have 0, and the square root of 0 is 0. Okay, so x is 0. But if you go back to the question, it says find the coordinates of point P. So all we have found right now is the x value. Okay, so we need to find the y value. How do we find the y value? We need to plug 0 into this equation. Okay, so I'm going to do 0 cubed plus 7y to the 4th equals 13. I want to know the coordinates when x is 0. Okay, so this first term is eliminated. We will divide by 7, so y to the 4th equals 13 over 7. And then to get rid of the 4th exponent, you need to take the 4th root of both sides. So we'll take the 4th root. Just like the square root, we actually do need to put plus and minus. So we're going to have the plus and minus the 4th root of 13 over 7, which is fairly odd looking, but it doesn't matter. So we have 0, and we have plus and minus the 4th root of 13 over 7. Okay, so we have the point 0, 4th root of 13 over 7, and 0, negative 4th root of 13 over 7. Okay, so I'm going to have you try now. If we have x squared plus y squared equals 5, find the coordinates of point P where the tangent line to the curve is horizontal. So again, tangent line to the curve is horizontal means the slope, I'll write m, equals 0. Okay, so I want you to take the derivative with respect to y. So the derivative of x squared plus the derivative of y squared equals the derivative of 5. So x squared will become 2x, y squared will become 2y dy dx, and the 5 will become a 0. We're going to isolate the dy dx, so we have to subtract 2x. Then it looks like we have to divide by 2y. And when you divide by 2y, these 2's will cross off. So you end up with negative x over y. Okay, so now again, we're finding the coordinates where the tangent line is horizontal. So that means set the fraction equal to 0 and ultimately the numerator equal to 0. That means when x is 0, we will have a tangent line that is horizontal. So what we'll do is I'm going to plug in 0 for x because we have to get the coordinates, which means we need the y value. We'll plug in 0 for x. So we have 0 squared plus y squared equals 5, which then, if we take the square root of both sides, so this 0 squared goes away. When we take the square root of y, we get square root of y squared, we get y. Square root of 5 is plus and minus square root of 5. Which then means when x is 0, y equals plus and minus square root of 5. So we now have these two solutions. This is where the tangent line to the curve is horizontal. And if you think about it, this equation is the equation of a circle. Okay, one second. Okay, with a y-intercept. Okay, so the radius is actually square root of 5. So they're saying the point 0, square root of 5, and 0, negative square root of 5. That means right here and right here. And if you look at it and you draw the tangent line, the slope of the tangent line should be 0. So we just use calculus to find those 2 points. But if you use your geometry and just graphed those 2 points, this whole circle, we would have figured out that that would be where the tangent line is horizontal. Okay, so what you're going to work on is questions 4 and 5. And I'm going to make a solution video for this. First question is, if you're given x squared plus 4y squared equals 7 plus 3xy, you need to show that dy dx is 3y minus 2x over 8y minus 3x. They are taking the derivative for you and showing you what it is. You need to just do the implicit differentiation and show the steps it would take to get you to this point. Okay? So pay attention to the signs and how they write them. So for example, the derivative of x squared is 2x. The derivative of 4y squared is 8y dy dx. Derivative of 7 is 0. And the derivative of 3xy, you have to use product rule. And what I would do is I would just assign the u to be 3x and the v to be y. So you're going to need the dy dx again in here. You're going to show that there's a point P where with an x coordinate of 3 at which the line tangent to the curve is horizontal. So horizontal means this slope should equal 0. And you're just going to plug in the number 3 in for x and solve for y. And then you are also going to find the second derivative. If this is the first derivative, we have to take the derivative of this, which means you are going to use quotient rule. Okay? Please make sure you use a bunch of parentheses, and every time you take a derivative of y, you put dy dx. Again, I'll be making a video going over these questions as well. Okay? If you look at question 5, again, they're giving you y squared equals 2 plus xy, and you have to show that the derivative is this. So you just need to show your steps, do the implicit differentiation, getting dy dx by itself, and then find all points xy on the curve where the line tangent to the curve has a slope of 1/2. Well, this equation represents the slope, so I would take this equation, y equals 2 over 2y minus x, and set it equal to 1/2, and solve for x and y. Okay? So do your best to work on these the rest of the period, and I'll make a video going over these two solutions. So please watch them hopefully on your own and to check your work.